All right, you guys ready over here?
No name?
It doesn't matter, guys. Everyone's here.
Oh, thank you.
You want to, or you done? Okay, sure.
So, what was your guys' experience writing some of the questions? What do you think? Yes, Kelsey.
I was just say I kind of had fun with it.
Okay.
You know, it was cool to like kind of think about it and ask some questions.
Yeah. Was it hard? Why was it hard?
You have to put your thinking cap on.
You do have to put your thinking cap on, yeah. Why? What was something that was difficult about it? Yes?
You can put answers that are too far apart from each other because then it's obvious, but it's hard to think of answers that are similar
Yeah.
to like mix it up a little bit.
Yeah, it can be tough, yeah.
I was gonna say what I tended to do for that is like where like say it was like I make like two-parters, so it's like two parts of the
Yeah.
answers in like two of them. So I would just switch it. So like you really had to be paying attention because if you were just looking for like one part of the answer, you might mix it up and be like, oh, there it is.
Yeah.
Like so that's what I do.
Yeah, so it's funny you mention that.
AP tested that for me.
Yeah, so you might put two parts of that are both correct, but they have to be correct in the right sequence. And if you switch them up, then you can basically catch someone who's jumping to say, oh, that thing seems familiar, I know those words are right, but they don't actually recollect the details of what came in the right sequence, right? Is that a hand question or a
Oh,
stretch?
about what you're
Yeah.
saying. Well, I learned that I need to study more. Because it was just like, I was like, man, I'm asking questions. Like, I don't even know I know the answer to that. So it was just like, yeah, it was good practice, but it just made me know that there's some areas that I need to focus more on
Yeah.
versus the other.
So it's a really good exercise too. Those of you guys who've had my class last quarters too, I probably said the same thing. In terms of getting ready for tests and stuff like that, get some study groups and write some quizzes for each other, write some questions. Because for me, not only was it helpful as a student to practice finding the answers, but really, a lot of the questions we get as instructors is often like, well, what's important? What do I need to know for the test? And those are very critical thinking questions to ask, right? And to have to answer. And if you have to come up with some questions on your own to test your friends in the study group or something like that, then it gives a really good opportunity for you to have to reflect critically and think about, well, if I only have 5 questions to ask somebody about assessing if they understand what we've been doing for 5 weeks, what are the key points that you want to be able to extract from them, right? That means if you can figure out 5 key points that you think have been important up till now that people ought to know, then you're thinking on the same wavelength I am, right? Which is now you're actually starting to game the test. Now you're actually starting to say, because I have to do that. I have to think, well, what are the key things that I think are important to test people on? And if you're already thinking about that way, then it's a good practice to like tap into, just practicing and thinking about what's important. And it also lets us practice filtering out, oh yeah, this is actually kind of trivial, or no, it's probably not worth asking about this thing, because that's really, really small fish type of thing. You know what I'm saying? Did you guys find that experience? That's what I usually find when I have to make
Sounds like
tests.
something I never asked about, but I end up asking a different question.
Yeah. So there's some really good stuff. People wrote some good things in here. So let's see here. What we got is some things about artifacts. What is drift in EEG? What would that be? Yes. Yeah. So you
Kind of
remember?
like from like swimming.
Yeah, so skin potential, something like that. So you would have that long, slow wave, right? And so the answer that was given was, what is a drift in EEG? The only thing I would mention is is not what is a drift, but what's drift. So this is just sort of semantic details. So you might ask, what's drift in an EEG? The options were given as a fast wave, or commonly recorded artifactual potentials, or crap. In which case, that could also be an answer, right? Because drift is an artifact. So you gotta be careful on writing those, right? The option given as the answer, correct one, long, slow waves, also correct, right? That slow, sloping drift wave. But it also followed up with a high-pass filter, in which case, you want to make sure that we have to make the question a little bit more specific, right? It's not just what's drift, but then the second part would be, and what's one way to accommodate that artifact, right? Which would be the high-pass filter to account for it. Oh, and here we said A and B, although that's also not. All right, these are good, good. Let's see here. Which of the following is not an artifact that can be found in an EEG recording? Is it A, saccade, B, blinks, C, EKG, or D, ERP? ERP, good, okay. Let's see here. True or false, the FN400 is associated with familiarity? True. All right. Let's see here. Hopefully you forgot to indicate what the right and wrong answer was.
Oh, yeah, sorry. Felt rushed.
Well, let's see here. What is a correct rejection? Yes.
It's where you correctly say that something, like that there's not a specific thing. So in our example of our experiment, where you correctly identify and word is
Okay. Good job. Let's see here. Ooh. Here we go. I like how this person's thinking. It's just what we got done talking about. They even have a citation in here. According to Picton et al. In 2000, as a general rule, it is okay, or it is fine to have tasks that is not designed specifically to elicit the cognitive process being studied. True or false?
False.
False, right? You do want to have that happen, okay? So I like the integration of Picton et al. That was thinking on your feet. Okay. Let's see here. Before you can perform an artifact rejection in MATLAB, what must you do first? Is it A, plot the ERP wave, B, compute the average ERP, C, bin operations, or D, plot data scroll? Plot data scroll. Good job. So we got to know our processing steps and the order of operations. Ooh, this is a really good one. So oscillations. We haven't talked a lot about those, but I know they're in the readings. We'll get to those, by the way. Oscillations can be described by what three pieces of information? Is it A, power, waves, and frequency, B, phase, time, and velocity, C, frequency, power, and phase, or D, frequency, power, and time? Huh? You said C. Any other takers?
Can you repeat
D?
the option?
Okay, so yeah, there's a lot there, right? There's a lot to digest. So we have oscillations can be described by what three pieces of information? Is it A, power, wave, and frequency? Is it B, phase, time, and velocity? C, frequency, power, and phase? Or D, frequency, power, and time?
Is it D?
It is not D.
It's C.
C.
C. Yeah, good job, Brittany. That's a really good question. So, when we talk about oscillations, what are we talking about? Yeah, oscillations and brain waves.
Yeah.
So, Neftali, would you be able to come share with us with some art and draw us an oscillation? Please? Pretty please with sugar on top? How about up here? Can you tell me how to draw it?
It's just like a little line, right?
So it's a little line like that.
No, like it's like over.
It goes up and down, right? It's oscillating, so it's changing. It's up and down.
Right.
Okay. So when we talk about oscillations, the question was, I'll use black marker so it shows up a little bit better. We can have an oscillation right? And we can characterize oscillations based on different pieces of information. And the answer was the frequency, the power, and the phase. So by frequency, we mean hertz, which we have talked about a little bit in class and definitely in the book. And frequency is basically telling us how frequently does that wave come back to its starting point. Let's say if it starts here, right? It comes down, up, and back, right? This would be one cycle, right? How often does it go through its cycle within a 1 second period of time? How frequent does it happen, right? And if it's a really fast frequency, this is, let's say this is 1 second. 1 second. It's really fast. Then it might go a bunch of times within 1 second, right? If it's kind of just one cycle, or it can be really slow, maybe half a cycle or a quarter cycle. So you can see different ways that we can measure the hertz. That's the frequency. The other one there was power. Okay, so power is a measure of amplitude. So you could have, amplitude is basically your measurement on this scale. Okay, so is it that we can have basically the same frequency but larger amplitude here versus the same frequency and smaller amplitude. Okay, and the third option there given was phase, which is basically, let's see if I can redraw this for us here. Okay, well let's move over one spot actually, and instead, so we can say maybe it cycles again from here to here, right? Up, down, up, back again. Okay, it could also come down, up, and back again. It's still a full cycle. The question is the phase. Is it in the peak or the trough? Right? So those are the three pieces of information. So it's a really good question. Man, you know you're reading the book. That's impressive. Keep up the good work. I really like it. Okay, so let's see here. We already talked about what does CRAP stand for, right? Commonly recorded artifactual potentials. Let's see here. How about, what does it mean when we encode something? Is it A, that we remember, B, that we memorize, C, that we study, or D, that we forget? Study, right? Okay, so these are loaded terms. We talk about the cognitive psychology of learning and memory. We're talking about making sure that we understand these stages of memory. So we have encoding, consolidation, and retrieval as three main phases. And so it's important to make sure that we understand what we're talking about, particularly so that we reflect that we know what we're writing about, and we'll later do it in our projects. Let's see here. What is the first step of data collection? Is it A, administering the experiment, B, giving the debriefing statement, or C, explaining the experiment and gaining consent? Yeah, definitely C there, explaining the experiment, gaining consent. Ooh, here's a good question. Can somebody explain what the inverse problem is? The inverse problem. I like this one. question. Okay, so if I were to say that the ERPs that we found at the scalp were due to hippocampal activity, what would you tell me? Yes?
That it's impossible to know like what cortical region like actually caused that. And
Okay, so you're going to be a hater at the bar.
Yeah.
You're just going to drink the haterade and you're just going to tell me, no, dude, you're wrong. It's impossible to know that. But why? Why would you say that?
There's an infinite number of possibilities.
Possibilities of what? There is an infinite number of possibilities. It's possible that I could be Batman. I might be. I can't tell you that, actually. The best one, whatever the best one. But, right, infinite possibilities of what is what I'm trying to get, right?
What cortical regions are causing?
Yes, there's an infinite number of what we'll call configuration of source generators. There's an infinite number of possible configurations of subcortical areas in the brain that could have contributed, possibly and mathematically, to the configuration of electrical activity that we can measure at the scalp. Right? And it's impossible to know for sure by working backwards. That is, it's impossible to do the inverse, to take what we see at the scalp and work backwards to try to know for sure what that initial pattern of generators were subcortical. Because remember we talked about that a while back? It's a really good question, really good way to think about things. How about change gears to ERP Lab? What does the event list option do on MATLAB? Yes, Kelsey?
The set number of like possibilities in terms of coding. Like remember we had like the 61, the 62, and 63 at the beginning of it.
Yeah.
And we have like this item the item source and like or source memory and.
So the easy, you're right on the right track. The easy way to think about an events list, right? So, Nicole, you said you did 30 subjects in practice. That's awesome. Very impressive. When you did the event list procedure for every one, the easy way to think about it is that you just use the word in its own definition. You're saying, I'm making a list of the events, a list of all possible 75 events of those codes of what could have possibly happened. So if you ever find yourself stuck on a question like that, don't panic. Take a deep breath in. You get 5 hours to finish the test, so it won't take that long. You have that time. I mean, we're in class. You can use all the. My point is to relax, take a breath. You can, you have plenty of time.
I was just saying it makes me think of.
Like goodness gracious, guys, come on. I'm sure.
I was gonna say it makes me completely counterbalancing what we learned about in Psych 311, where you had to like multiply all, like it was like you have like 5 groups, you multiply 5 by 4 by 3 by 2. That's your whole complete counterbalancing. So it's like in the events list is like all the possible.
Well, the events list isn't about counterbalancing. You want to counterbalance conditions. Not that's not exactly what the events list. Events list is just a list of all possible events that could have happened. And a lot of them are empty because most events don't happen, right? You don't get these weird, wacky combinations that people wouldn't typically respond with. But it gives us the option to categorize at any times that they do say something. So that's really useful. Okay, so let's see here. A couple other ones. What's the first step you want to do when you open MATLAB?
Pray.
Set your path. What'd you say?
Pray.
Pray.
That is true.
Yeah. Equally true, could have been cry. But scream to the void, no. You want to set your path and then pray. Yeah, so, okay, that's very good. And let's see here. Which of the following would be considered a miss? Saying something's old when it's really new. Saying something is new, but it's really old. Saying something is old, but it's really old. Saying something's new, but it's really new.
Saying something new. Saying something is new,
But it's actually old.
Yes. You're missing something that should be there. Exactly. Okay. Let's see here. These are all good ways of thinking about things. Ooh, what EEG sites are often used as a baseline for looking at data in terms of location? So let's see if I can reframe this. Which EEG electrode sites are often used as a reference? Yes. Yeah, the mastoids. Now, a little note on that. So if any of you guys had read the luck book, you'd respond back to me and say, that's totally arbitrary, and you'd be totally right, right? You can pick any site you want as your reference. Often, exactly. And so the reason we tend to use the mastoid is the same reason that the textbook recommends, in this case, particularly probably using the mastoid, but it's because we want to compare our effects that we hope to discover and that we're hypothesizing about in EEG of memory to other effects that we've learned about in the literature that have motivated the conducting of our studies. And so you want to basically select a mastoid that's consistent with what other studies have typically used to get your effects, because your choice of the reference site is going to change the spatial distribution of your effects. So that's an important point to remember. Let's see here. What is an advantage and a disadvantage of ERPs? One of each. Good temporal resolution is an advantage. You didn't speak up? Okay, so hit me with a disadvantage.
lack of visual.
Hold on. Share it. Okay. No. You're up, love. It's all you. Disadvantage of EEG. Relative disadvantage.
Of EEG?
Yeah, or ERPs. Yeah, they're relatively poor spatial resolution. Now we always say relative, right?
Relative.
Right. So I want to make sure we get our terminology down. No, it's all good. I mean, you're right on track. This is what I want to do is use this to kind of like iron out things to get it really dialed in. Okay. So let's see. If you're using the confidence scale to study item recognition, what numbers on the confidence scale would be useful to reflecting when people are using familiarity to make their judgments? Somebody besides Kelsey. Yes, Ryan. 4 would be a really good choice. Now, 5 would also reflect really familiar information, right? But why did I kind of steer it away from 5?
Because 5 is when you actually know you recollect it.
Yeah, so it's actually a combination of both. So 5 is when you're definitely confident, which means it's probably recollection. But if you're recollecting, it's also probably familiar too, right? And so the usefulness of the 5s is that they help to give us the indications of times when it is recollected, because you're not going to see that in the lower confidence responses, right? Which would be 4s, maybe even a little bit of 3s bleeding into, right? When things are a little bit familiar. So you can use 5s would reflect some familiarity, but the problem is the problem for why we don't use the 5 responses to indicate familiarity is that we can't reliably pull apart recollection familiarity contributions to the 5s because they're both in there, unless you use the source information to help you out. So if you say, and you guys can, I'm hoping that somebody's going to make some hypotheses about this in their projects, because it's a really interesting question, right? So if we have a word on the screen, right? So give me a sample word to use.
Tree.
Tree. 1, 2, 3, 4, 5 for old. New options. And let's say that you say 5, right? And we say, okay, well, the idea is that there's a threshold of recollection such that when you exceed it, our high confidence responses will show that it's recollection. But that we also know that there's a gradient of familiarity, right? Such that there's a lot of familiarity on this end and a relatively smaller amounts for the 3s and the 4s. Right? So you give a 5 response during item recognition. And the question that we're discussing is, how do you know if it's reflecting recollection or familiarity? And the answer that Fitria offered very insightfully is that you can draw upon asking them for more information about their memory experience, in particular, the source memory question, right? This is why it's really useful that we have this. So then we ask it this question, right? We keep that word on the screen, and we ask for their source memory. No, let's say this is source correct, and this is source incorrect, okay? And let's say that they say you can compare times when they say 5 and then go on to give a 3 response saying I don't know, versus a different time when they might say 5 that goes on to give a highly confident correct source, versus when they say the source is unknown. Alright, so you compare that. That would be times when they say 5 plus source correct. And you would compare those ERPs to the topographic maps versus times when they said 5 plus the source unknown, or SU. So you'll see that in your bin operations files. When you go and plot your ERPs and you're plotting your, so this would be a difference map. So you would plot ERPs for this condition versus ERPs for this condition. But you could also then find a difference bin that subtracts those two and plot that topography too. That's a very interesting theoretical hypothesis that you could explore in the data. Right? Now, you'd have 2 hypotheses about that, wouldn't you? How would that guide where you're going to explore in the data? So one possible hypothesis is that could be based on recollection, and the other times is that it could be based on familiarity. And so you both look at the early time point and the later time point in the EEG, right? About 3 to 500, and then maybe 6 to 900. And you look at different spatial topographies in the midfrontal effect for familiarity, or the left parietal effect for recollection. You can make that hypothesis about what's underlying that really interesting cognitive phenomenon. Right? It's a question we don't have an answer to yet in our conversation, right? Therefore, you could draw upon our physiological data set to try to answer that question. What is contributing to the 5s? Or what times do the high confident item responses reflect familiarity, and what times do they reflect recollection? That is a question that you're not going to be able to answer with pure behavioral data, but which we can draw very usefully upon a resource of physiology to help understand that phenomena of cognition. Yes?
So let's say we have a participant, right, that every time they have the 5, they also get they have like a mix between the 3s and the 5s,
Yeah.
right?
Well, the first thing you can do is you can look at the reaction time differences between those conditions.
Okay, the reaction.
Do they respond quicker for this or slower for that?
For that.
And And then you'd also then look correspondingly at the EEG. So you can look at the behavior too. Actually, I could have made my earlier statement. Good catch. Okay, cool. So that's some stuff there on what the confidence scale could measure. What's the main purpose? We just talked about this a little bit. What's the main purpose for ERP bin operations in the MATLAB program? Is it 1, to compute averages, or A, that is? Is it B, to load lists, C, to plot waveforms, or D, to label different categories? Listen. D, label different categories, exactly. You're operating on the bins. You're taking individual ERP conditions and you're operating on them to make a difference wave, or an average. So you're creating different labeled categories of our different initial conditions. And let's see here. What is epicing the data do? Somebody besides Kelsey, you're on top of things today. David, what does epicing the data do? That's definitely correct. It is definitely setting it up for artifact rejection. But how does it set up the EEG for artifact rejection? What's the step that epicing does more descriptively that allows us to reject artifacts? It does definitely set up the time frame. So what do we start off? What's the data look like before we epic it? Yeah, it's one long time period, like a whole hour, right? What does it look like after we get done epicing? That gets it ready indeed, as you said, for artifact rejection. Not quite. So we don't want to say plural EEGs. We would say plural ERPs. But we're not quite. We haven't created ERPs yet. So EEG is like this. You want to use the singular tense on that. And so you still have one long epic of EEG. And you want to epic the data, so you slice it into smaller time points, right? That's how we can actually identify the artifacts and reject them, because we've sliced it into discrete time points that can be kept or rejected. Remember? Make sense? Okay, awesome. So how do you guys feel with all that stuff? Is it a helpful exercise?
Yeah.
Okay, cool. So
I'm not sure if you're explaining things better or I'm getting it.
I think you're
Either or.
I think you're probably getting it better. I'm not going to give myself any credit for doing a better job. I think that you're doing a better job, and you've worked very hard and are now able to integrate it. Which is something we know about memory, that repetition helps us to remember stuff, and we keep repeating stuff, so you're on track. Okay, so you guys feel pretty good about this stuff? Helpful exercise? Okay, why don't you guys want to take a break?
Yes, sure.
Okay, let's take a break, and we will reconvene and dive into some data analysis, doing new things that will be on the test. Okay? Good deal? Let's do it.